So thank you everyone for being here. I am very pleased and grateful for being here today. I'm a master's student in Sustainability Science at Universidad Nacional Autónoma de México. And I'm going to present you a research that I've been working with my advisor, Luis Bojórquez-Tapia, and my coworker, Ileana. The research is based on the development of an AHP-based social vulnerability index for small-scale fisheries in Yucatan, Mexico. We offer a robust and transparent methodology for the measurement of adaptation processes of small-scale fisheries, addressing the uncertainty that arises when developing an AHP model, such as the modeler's background linked to the differences in their preferences, knowledge, and experiences. So in order to address such uncertainty, we performed two sensitivity analyses. The first one was with the purpose of highlighting the individual effect of each participant on the aggregated results of our model. And the second one was to obtain the rank reversal probabilities of our alternatives. Our research question was, what are the consequences of considering an expert or not considering an expert? And of course, our objective was to obtain the most important alternative. So let me start with another question, that is, what is vulnerability? What does it imply? Within the specialized literature of sustainability science, vulnerability has been defined as the state of people or places that are differentially affected by hazards. The response to those hazards depend on a combination of social, institutional, and environmental drivers, as well as the society's adaptive capacity. So here I would like us to focus on two concepts: social institutional drivers and society's adaptive capacity. To make it simpler, let's just stay with drivers and adaptations. So let's picture those concepts on this example. We can say that drivers are the objects surrounding our system, which is the red balloon. These drivers are the events that can trigger a change. So, maybe we could, if we punch the balloon with a needle or a knife, it may explode or deflate. So this change would be our adaptation. So let's take all the theory all the way to the Yucatan coastal zone, specifically to the small-scale fisheries. We chose this social group because fishing is one of the most important activity in the state, and also because they have been described as complex, multi-species, multiscalar. All those concepts just refer that there are a lot of factors affecting small fisheries, so they are highly vulnerable. Taking our last example, we can say that, either the modification or implementation of a new law, market demand, surveillance, or maybe species prices could trigger a change in our small-scale fisheries. So the questions here are, what kind of combination of such drivers would lead to a change, and what type of change? And the other question, of course, it would be, how can we measure such vulnerability? Well, the quantification stage is typically achieved by the construction of indices, which are basically a simplification of multidimensional factors into one simple metric. And the AHP has been widely used for the construction of such indices. As we can see here, we developed a hierarchical structure from literature and field work. In the second and third level, we can see our criteria. They are the social institutional drivers. We chose three clusters: economic, governmental, and social drivers, and we subdivided them in three sub-criteria. And the fourth level is they are our alternatives: abandonment of the fishing activity, change in social organization, change in the fishing gears, and migration of the coastal zone. However, we wanted to acknowledge the different perspectives of the same complex problem. So we ask for experts to judge our structure. Here are the pairwise comparison matrices resulted. And well, in the rows, we have the pairwise comparisons of each expert, and in the columns, we have the criteria. Here, well, our problem arose because we could notice that the differences between the judgments of each expert were, really highly significant. For example, the environmental policy expert judge price as even extremely important than markets and employment. So these differ significantly from the other experts. Here are another examples for governmental drivers. Political science expert judge policy as more important than comparison law. And for the social driver, fisheries biology expert judge surveillance more important than processing and sowing. So, well, who's right, who's wrong? We focused on this particular question: whose pairwise comparisons affect the most on the overall average result? We perform a sensitivity analysis that highlights which individual most critically impact the aggregated group results following Ivanko and collaborators. And we obtain the aggregated group weight, and we made perturbations on each element of each pairwise comparison matrix of each expert with a perturbation value of 1%. So here are the results. As you can see, for each criterion, it differs. Well, the expert that had the highest sensitivity value. For economic and governmental drivers, we have that the environmental policy expert was the one with the highest sensitivity value. So he was the one that most affected, or most with the highest effect on the aggregated results. And for the social this one, we wanted to explore this of integrating the one expert, and also we wanted to know the rank reversal probability of our alternatives. Therefore, we chose to generate two versions of our hierarchy. One is the model one, taking into account experts, and the other model two without taking into account the environmental policy judgments. We perform the interval judgment analysis following Sari and Vargas. We obtain interval judgment matrices with the minimum and maximum pairwise comparisons, and by means of our studio package, we obtain 50,000 random pairwise comparison matrices. Then we obtain the normalized weights, the ones that were consistent. Scenarios. The first one, when our P was 0, we had no of the our weights. And the second one was when we had overlapping but not as subsets. And the third one was when our criteria were subsets. Here are the results, as you can see in model 1, model 2. Are the and we could for example, we have price for the most, and it went to the list. And for employment, it was important to in weight. So as for the probability of rank reversal, we had that also had differences. For example, between employment and price, in the first model, we have that
Tatiana, you have 2 more minutes.
Oh?
Yeah.
And for the governmental, it went to 8%. So for those criteria with probability of 50, we chose of as the waste. Graded result. Okay, so have an here and migration adaptation didn't much because they see other places. As for the, abandonment and sorry, I had a mistake here. And social organization adaptations, we can see that well, organization when was under to acknowledge more information of the model and why having those, so we could exchange more information to the others, so they could select the best model of the two options to measure social vulnerability, small-scale fisheries. So that was for me.
I cannot hear you anymore, Tatiana. I guess. Oh, okay. Now I hear you.
Okay, now.
Yeah, I can hear you now.
When you lost me, sorry.
Okay.
Okay.
Thank you so much.
Can you hear me now?
Yeah, we can hear you. And you are done, right, Tatiana?
Yes.
Okay.
Yes.
Thank you for this nice presentation.